Good morning, students. In this video, we are going to discuss about stack. It is a linear data structure. In this video, um, mainly we are going to discuss about the following topics: the basic principles of stack, operations performed on stack, stack creation using array, stack implementation using linked list, applications of stack. These are the main topics going to be discussed in this video. So the first one is the basic idea. What is a stack? Examples, real-time examples for stack. Stack is an abstract data type commonly used in most of the programming languages. It is named as a stack as it behaves like a real-world stack. For example, a deck of cards or pile of plates. Stack means the elements arranged one by one. So one on the another one. So if you wanted to remove the last one, you need to remove the previous n minus 1 elements. Then only it is possible to remove the last nth element. Okay. So stack is an abstract data type used to store elements. It is a linear data structure. Stack is represented like this as shown in the diagram. Last in, first out. The element which is inserted lastly is to be removed or deleted first. Last in, first out. So that it is also called LIFO. So stack can be represented using either array or linked list. The operations performed on a stack are push, pop, creation, is empty, is full. Push operation used to insert an element into the stack. Pop operation is used to remove an element from the stack. Creator is used to create a stack. Is empty is used to verify whether the stack is empty or not. Is full is used to verify whether the stack is full or not. So the basic operations defined on a stack are push operation, insert an element into the stack. For this we need to pass elements to two parameters. One is the stack address and another one is the element to be inserted. Pop operation, for this we need to pass only one parameter, that is address of the stack. Create, it is also used to create a new stack. For this also we need to pass only one parameter, that is address of the stack. Is empty, for this also we pass stack as a parameter. It is used to check the stack is empty or not. Is full, it is also used to verify the stack is full or not. Stack using array, stack implementation using array. So push operation, initially the pointer points at lower index of the stack. The pointer always points the top of the stack, so that it is called the top of the stack. So when one element is added to the stack, the top is incremented by 1. Here look, the top is changed its location by one element. So one element is, when one element is pushed into the stack, the top is incremented by 1. Pop operation, it is used to remove one element from the stack top. When a element is removed, the top is decremented by 1 as shown below. It means the pop operation is executed. Now the array implementation using linked list. First one is push operation. Add an element at the stack top. The initial value, it is the top. So top always represents the last element in the stack. So if you want to add an element at the stack top, that is called push. Simply it is like this. The new element is added to the previous top element, and now the new element's address is saved in top, because from now onwards the new element is the stack top. Pop operation. Remove one element from the stack top. It means the top stack top pointer decremented by 1 and deallocate the top element. So it is shown below like this. What is the basic idea? In array implementation, we would declare an array of a fixed size which determines the maximum size of the stack. Keep a variable which always points to the top of the stack. In the linked implementation, maintain the stack as a linked list, and a pointer variable top points to the stack top of the list. First element of the linked list is considered as the stack top. So pseudocode implementation for stack declaration using array using linked list. So the left side box represents array implementation. Right side box represents linked list implementation. So in array implementation, the stack represented using a structure named LIFO. It contains two elements. One is the stack, and second one is pointer top, stack top. In the linked list also same. It is represented as a node. Each node have value and pointer to the next node. Next, stack creation. To create a stack, simply stack top. Initially the stack top is initialized to -1. That means the stack is empty. Here in linked list, stack top is equal to null. If the top is equal to null, it means the linked list is empty. Push an element. To push an element, first increase the top pointer by 1, then after assign the element to the stack top. Whereas in linked list, to push an element, simply increase the top pointer, create a new node that stores the new element and add it to the end of the linked list. Stack top. Push an element into the stack means simply add an element at the end of the list. Next, pop an element, that means a remover. In the array implementation, simply we decrease the top value by 1. Then it represents the next element in the stack. Whereas in linked list representation, remove the last element of the linked list. Remove the last element of the linked list. How to check the stack is empty? If the stack top is equal to -1, it means it is empty. Whereas in linked list representation, if the stack top is equal to null, it means the stack is empty. If the stack top is equal to -1 in the array representation, then we say that the stack is empty. In linked list representation, if the top is equal to null, then we say that it is empty. How to determine the stack is full? If the stack top is equal to n, then we say that the stack is full. If the stack top is equal to null, we say that the stack is full. In linked list representation, applications of stack. Stack is used in so many applications like page visited history in a web browser. The recently visited pages are available at the top in the history. Undo sequences in a text editor like a Ctrl Z. Whenever you press Ctrl Z, the recently modified updations are undo. Next, validate XML or chain of method calling in the Java virtual machine or recursive function calling. Indirect applications are auxiliary data structure for algorithms, component of other data structures. All these are the examples for applications of stacks. So one of the best application of stack is infix to postfix notation. So before describe how to convert infix to postfix notation, first we need to know what is infix and what is postfix. Infix means operands and operators are placed in between operands. In postfix, operators are specified after the operands. Infix to postfix. Here are some examples for infix and corresponding postfix. A plus B, it is infix. Its postfix is A plus B, AB plus. A plus B star C, it is infix. Its postfix is ABC plus, star plus. A plus B. First we execute or we convert the parentheses. So A plus B write as AB plus, next C star. So next one A plus B star C plus D. So first we give priority to the high priority operation. So here the high priority operation is star. So before that A plus B, AB plus, next C plus D, CD plus. So first we execute the star operation. So B star C, so BC star. So BC star A plus. So ABC star plus D, D plus. Here first we execute or we convert the operations within the parentheses. A plus B converted as AB plus, C plus D converted as CD plus, in between star. Next A star B plus C star B. So AB star CD star plus. A plus B star C. It is nothing but parentheses begin A plus B star C close and close. So BC star, first we evaluate B star C as BC star. Then after A, ABC star plus. It is also another example. It is also. So now what are the steps we followed to convert infix expression to postfix expression? Use a stack for processing operations. Scan the sequence of operations and operands from left to right and perform the following steps. Output the operands as it is. Push an operator of high precedence. Pop an operation. and output till the stack top contains operators of lower precedence and push the present operator. Infix to postfix conversion requires operator precedence information. So operands add to positive expression, close parentheses, open parentheses. So pop the stack symbols until an open parenthesis appears. Whenever the input symbol is closed parentheses or right parentheses, we need to pop out the elements up to a left parenthesis is available. So pop all stack symbols until the symbol of lower precedence appears. End of input. Pop all remaining stack symbols and add to the expression. So it is one example how to convert a infix expression to its equivalent postfix expression. So initially the first one is operand, so write as it is. Second one is a star, so push it onto the stack. Next parenthesis begin, it is also pushed onto the stack. Next B, displayed as it is. Next plus, push onto the stack. Next C, displayed as it is. Next one is star, push onto the stack. Next D, displayed as it is. The next one is closed parenthesis. Once a input symbol is closed parenthesis, pop elements up to left parenthesis available, so that star plus also removed. Next only one operator star is remain in the stack top. So next one is plus. So plus precedence is priority is less than the star priority, so that the element star removed from the list. Next operand E, so it is displayed as this. So it is about how to convert a infix to postfix expression. Thank you.